Welcome to IC Education, the only education that matters. Laplace Transform. What are we gonna do here? They said multiplication by chi, using Laplace of differential equation, using poles to determine stability. Okay. Now, what did happen here? Remember, what I do is not enough. Mr. Trinish, what we're gonna do is we're just gonna be sharpening two examples and applying the cases that we have, right? I think that's gonna be quicker and easiest way to move to. So hopefully today we can cover until multiplication by chi, inverse Laplace. Yeah, we can cover until maybe differential equation. Okay, there we go. Definitions, what so. Okay, how do we use Laplace? Laplace is just application of formula. For instance, do you see this example, right?
Yeah.
I'm sure you know how to do it, right? Okay, let's just make a quick recap. It's fine.
Do it.
A quick recap. Let me close this one. Okay, now Mr. Trinichi, when it comes to Laplace, what do we do? This is just simple Laplace. What we do is we just apply formulas. Like for instance, you are asked to solve for Laplace of this and this. Now, what do you do? I don't know if you have the formula sheet with you.
Yeah, I have it.
If you do have the formula sheet on the Laplace, Mr. Trinichi,
Yes.
simply what you gotta do is, you know that Laplace of exponential, you know that Laplace, if you can just recall it quickly, Laplace of exponential, let's say bt, is simply equal to 1 over p minus b. So,
Yes.
if you want to apply this here, you'll have minus 3 exponential. No, we don't longer put exponential. Okay, first of all, in Laplace, you can split this. Do you agree? It's
Yes.
like integration. You can write it like this. But you don't really have to write it like this. So,
Yeah.
it does not really matter. But let me just write for the sake of people that will watch the recording. Now, Laplace of this will simply be minus 3. Now, you have 1, p minus b. There is p, there is minus of the formula, and this minus here, that makes it 2.
That's true.
Now, plus, in this case also, you have 5 as a constant out. You apply the formula. What is sinh?
Sinh is A over P
Sinh
squared.
is a over p squared minus a squared.
Yeah.
A is the constant inside here. So, A is what? It is 3.
3.
Yeah. P square minus a square. What is a square? A square is 3 square, which is 9. So minus 9. If you done this, you've solved the Laplace. I just want to confirm something. On this textbook, is it using P or S? Okay, it's P. Because some other books they call it S. Now, Mr. Trinici, let's do this one here. This one they say the first transition for the translation property. This is basically when you've got exponential with cos. How do you go about it? There's a formula about it. There is even a formula, but let's apply the first transition formula that they are using here to see how it is done.
Yeah.
Okay, now what is happening? Laplace of, yeah, I'm gonna print it. I'm not gonna write today. Today, I'm gonna print. My phone is full of screenshots now. Today I don't feel like doing anything. Okay, what are they saying, Mr. Trinici, in this case? They are saying that Laplace of f of t equal to this, and b is a real number, then this is equal to f p minus b. If you see the Mr. Trinici, there is a formula for this one.
Yeah.
For e and cosh. But there's also a way of doing it.
Yes.
I don't think this is necessary. Doing it like this. Do you know why I'm saying that? What they are doing here, according to the formula, Mr. Trinici, you first solve for the Laplace of cosh.
Oh gosh.
What is Laplace of cosh? Of cosh q theta. It gives Laplace of cosh is p.
Oh. A over p. Yeah? What is it?
Cosh
P
is p.
over p squared.
Yeah, it's p over p square.
Minus a squared.
A square here is 4, right?
Yes.
So you have something like this. Now you got your limit of p here to substitute to be p minus 5. So p minus this one here. So it means you will now come here and substitute where there is p. You will have p minus 5.
Yes.
Where there is p, you have p minus 5 square minus 4. So literally this one has a formula for it. Like there's a formula you can look for the Laplace formula. There's a formula that can give you this straightforward.
Yes.
So there's no need of wasting a lot of time there. What is the second one? They say the second translation property is L of f of t and k is constant, where f of t is this, what, so. Now what do we do? They said L of a, it is a f over p. Come on guys, this one is formula, Mr. Trinici.
Yeah, it's just
What is if we want to solve for, yeah, sin a, it is ap. No. Let's move to what is interesting. You don't have to do it like this. You can apply the formula straight, and Bongo will not ask such thing. Are you sure the book you are using is the same, my friend?
Yeah, it's the one that you are using. Yeah.
I think what is very, very important here, is applying the Tn formula property. What is this idea? What is being explained on the Laplace transform of the integrals? This is what is very, very important. Now they say determine L sin 4 using Laplace transform of the integral. What does the formula says using Laplace transform of the integral, Mr. Trinici? It says that Laplace of the integral of f of u du is equal to f of p divided by p. Can we apply it here first on this simple one, Mr. Trinici? So that we understand what's going on. So we are here. I'm still gonna print again. No, this one I can write it. Let me not be lazy. It's printed. Right. Okay, they said using the integral. First thing to do, Mr. Trinici, they said the formula of the integral, basically, it says that it is f of p divided by p. F of p is simply the solution of the Laplace. So let's get f of p. Using the formula, what is sine 4t? It is a, what is a? 4. Do you agree, Mr. Trinici?
Yes.
What is
P
squared?
P squared plus A squared.
P squared plus 16.
Yes, plus 16.
Plus 16. This is our f of p.
Yes.
So if we have to solve it, now we're definitely going to have 4 over p like this, multiplied by p squared plus 16. Do you know why is it p, Mr. Trinici? We just divided the whole solution by p.
Oh, by p, yes.
And this is how you solve it. Easy as it's easy as it's there.
Yes.
I'm coming, Mr. Trinici.
Sure.
Des bonnes petites langues. Apparently they're coming from home. Je lui avais plein de petites envies. Apparently coming from home.
Yes, Mr. Trinici, can we move to the next one? So if whenever, that's how easy it is. If they say solve the, if you read the question, they say solve the Laplace using the integral formula. What you simply do, Mr. Trinici, is you get your solution like this, and then you divide by p. Easy as that.
Yes.
Yeah, multiplication by chi. This is very, very important as well. The only thing that you need to know here is the formula. Here is the formula of multiplication by chi. What does it say again?
Yeah.
I hope this is recording because I made a mistake earlier on. I was having a class, it was not recording. Let me see if it's capturing my screen. Yeah, it does. Now, what is the problem here? The problem is solve for the Laplace of cos of tn here. Yeah, I do this one. Of t cos 2t. You have to solve for the Laplace of t cos 2t. I'm gonna try to write bigger. Pourquoi moi je le foutais avant? C'est dur.
Il a déjà commandé, c'est sûr.
Hein?
Il a déjà commandé pour toi, c'est sûr.
Je n'ai même pas appelé pour ça. Hey! What's happening, Mr. Trinici? Oh, was I copying?
Oh man, I'm doing my due diligence.
You are doing your what?
My due diligence.
What is the diligence?
I think it means something I should do.
Oh, yes, Mr. Trinici, what do we do here? The formula says here it is minus n. Minus 1 to the power n. So in this one, what is our n? It is 1. Do you see, my brother?
Yeah.
So it's going to be minus 1 to the power 1, which is minus 1.
Yes.
N is the power of this one. And then
It's
they
the power
said
of t.
is the power of t.
Yes.
And then they said g
D
N is if this one is 2, you're gonna differentiate twice.
twice, yes.
Because it's 1, we're gonna have d over dp.
Yes.
Here is f of p. F of p is simply the solution of the Laplace.
The Laplace.
So what we do here, we have to solve for the Laplace of cosh 2t.
Yes.
Applying the formula, what do we have?
P over P squared minus
It
4.
is p over p square minus 4. P over p square minus 4. So the solution that we got here, we can bring it in our formula, which is minus d dp.
P.
Now we have p minus p square minus 4. So here we can now differentiate this one. So how do we differentiate this one? It is the quotient rule, uv prime,
Yes.
which is u prime v minus v prime u over v square. So if we do this, u is p, right? Your u is
Yes.
p. What is your u prime, Mr. Trinity? 1.
Yes.
Your v is p square minus 4.
4.
What is your v prime? It is 2p. So what do? We can just now apply to the formula. If we have to apply, we'll have, we don't have to forget the minus in front. This minus. Now we have u prime v. U prime is 1. V, it is p square minus 4.
Minus 4.
Minus of the formula. V prime u, it is 2p multiplied by p, which is like this, right?
P squared, yes.
Yeah, what is v square? V square is simply p square minus 4 square. Everything square. So now we can think of simplifying, meanwhile multiplying this. Do you agree that minus 2p square plus p is p square, Mr. Kenichi?
Yes, it's P
It's
squared.
minus p square. With the minus multiplying here, we'll have p square plus 4.
Yes.
So you can even, yeah, it says like this. This is the final answer. As easy as it is, these are just some basics, and I'm pretty sure that's what they got. P square, this. So what do we need? Can we try? Okay, this one is very, very important. Okay, do you see that, Mr. Trinity? This one is more or less like what we had here. You have t, you have exponential. Do you see it?
Yes.
And you have this. How do you deal with it, Mr. Trinity? First of all, you solve for cosh and chi the way we did.
Yeah.
Now, at the end, that answer, you need to substitute p by the value of this. It is always minus. What if it was minus here? What would be p here, Mr. Trinity?
Positive.
Yeah, that's just definitely what's happening there. Okay, we also have what we call division by chi. Division by chi, it's very, very important. This is even where most of the question comes from. Can you, this guy, why are you calling me? Bro, I haven't forgotten, my man. I'm just busy. I'll send you what you're asking when I'm free.
Everyone wants a piece of me. Tu as besoin d'un assistant, je suis là. Je vais t'assister.
I'll hire you, Gigi. I can hire you, you respond to my calls.
Tu vois comment on s'est coupé dans les 3000. Tu enlèves seulement. fini? Yeah. Oh, il y a quelqu'un qui fait brûler les choses. Avant, ne blague pas, hein. Avant, il est chaud, hein. Yeah. Bon, je suis là, j'ai lancé à l'école pour toi. Mais seulement pour l'écho.
Yes, Mr. Trinity.
Sure.
Sorry, my brother. I need to plug my data even. Now, what is happening here? Division by chi. What is the formula saying? First of all, we have to prove existence. Yeah. How do we prove existence, Mr. Trinity? What you simply do is you substitute the limit of chi going to 0 under this equation. Let's do it. Let me print.
Yeah, this is
Let's
good.
do it. Ish, I don't know.
Va descendre de l'interne,
J'ai dit ça à 13h après la classe. Mélange. Après mélange, je vais chez lui. You like cut 0, ne? You like cut 0? Are you sure? It's a scam.
I mean, it's better than. C'est mieux que l'autre. L'autre, il a l'air le point normal quand tu vois, frère. Tu sors ici directement.
Okay, the formula says limit of t is equal to f of p. First, we have this. We provide first, Mr. Trinici, the existence. The existence is we check first for the limit of t going to 0. F, so this one. So what we do, Mr. Trinici, we have to check the limit when t is equal to 0. Let me try to write nicely. When t goes towards 0 of sine 3t over t. Now you will notice, you will see something here, Mr. Trinity. If you substitute t here on 0 here, it gives you infinity.
Yes.
So what we do here, we differentiate now. This function here, you differentiate on top. Do you see it?
Yeah.
You have your limit moving t toward infinity, toward 0. You differentiate on top. What do you get? You get 3 cos 3t. Do you see it?
Yes.
You differentiate down. What does it give you? 1. So now when you substitute here 0, you will see that your limit is 3. Because it is a constant, now you can confidently come and say, just like here, you can say that we have an existence. Since the limit exists, so it means we have the existence. Now we can recall this equation and start solving for it.
Would you have to continue differentiating if it still gave you?
Yeah, you keep okay, you see it's division by chi. It is not
Yes.
division by chi n. It will always be chi. I don't know if I'm making sense.
Or always the T?
The longest is power 1.
Oh, okay.
That's the longest that you can have. That's the longest that we can have.
All right.
Now, what is happening here? What do we? Okay, let me just print this, Mr. Trinity, so that we can all be on the same page. I just want to see by the formula. They say this. Then L of t is equal to L of f of t to this is equal to limit of p to the infinity of fu of du, provided by the limit existing. Last time I was on fire. Today, where's my fire? Okay, how do we solve this? Because 3 exists, Mr. Trinici. So what we do is, we have the limit of this to this should be equal. Let me just rewrite it so that it can make sense. We have the limit of sine 3t over t, like this, to be equal to the integration of p. Oh, what's going on, God? What's going on now? Oh, what is this? I lost what was there, but anyway, it's fine. They said it is limit of p, 3 to p like this, Mr. Trinici, of the infinity like this. Now, what we do here, the function has to be in terms of du. So basically what they say of f of u, what you are doing, Mr. Trinici, what is the solution of sine 3t? Of sine at? It is a
The Laplace.
Laplace, I mean, yeah.
Yeah, it's a p squared.
What is a? A in this case is 3.
It's 3.
Instead of p now we'll be using u.
Put u.
Yeah, which is what? U square plus 9.
Plus 9.
Yes. In terms of du. This is basically what's happening here. So you prove first the existence. What is this one? And then you come here. So basically what you are doing, Mr. Trinici, you are solving for this integration now in terms of du. So what is the integration of... Do you understand what I'm doing, my brother?
Yeah, no, I understand.
Okay, what is the integration of 3u square 9 here?
It's 10.
Hey, Scalas Banding integration 1 is u square 9. It has to be
10, 1 over 8, 10 inverse.
It is what? Okay, I see where you are going, my friend. There are formulas for it, ne?
Yes, it's formulas.
What are the integration formulas? If you have this one, give tan. Yeah, yes. You are right. If you have f of x, is like this the formula, I think. Integration of f prime of x
a squared
f of x square, right?
Yes.
Plus a square. What is it equal to? They say it is minus 1 over a tan minus f of x over a.
Yes.
So can you apply it here? Remember, f of x in our case it's u, Mr. Trinici.
Yes.
That's why this formula actually works. So we can take 3 outside. Do you agree?
Yes.
So that we can see it as p infinity 1 u square plus 9, everything to be du. Now we can apply now that formula, Mr. Trinici, that we are using there. So what we'll have on this integration, 3 is outside. We will have f of x is u. That's why when you differentiate you have 1. So applying this formula, they say it is 1 over a. So it is 1 over. What is a, Mr. Trinici? Remember this formula is a square. Eh?
Yes.
A is 3, right?
Yes.
Multiply by the inverse. What is f of x? F of x is u. What is a? A is 3. So the 3 will cancel 3. Do you see it, Mr. Trinici?
Yes.
So we are only left with the inverse of 1 of u to 3. Now, what are the limit? Our limit is from p to the infinity. Now we can do upper limit minus lower limit. Where there is u upper limit, first we're gonna have tan infinity inverse infinity over 3 minus tan infinity of p over 3.
Yes.
So I guess that is what they got. Yeah.
Referring to the PZ video.
You saying, my friend?
It's a prime. Yeah, no, nothing, man, nothing. Oh, yeah, sorry, man, sorry.
No, it's fine. You can talk. If you're on the phone, you can talk. I'll wait for you.
No, it's not me. It's Brian here.
Oh, Brian is here.
Yeah.
Hey, Ice.
Hey, my friend, it's been a while. You don't even talk to me.
Huh? No, Ice, man. Hey. Yeah, I'm around. How's it?
I'm good, my brother.
No,
I'll be around when get there. If I'll give you a call to greet you guys if you guys are still there.
Oh, all right.
Sure, thanks, my brother.
Oh, man, take that.
Sure.
Hey, Mr. Trinity,
Yes, Ice.
my brother. Okay, remember we have infinity, right?
Yeah.
Tan infinity over 3 it still gives infinity. Remember, infinity is a very big number. That's why we call it infinity.
Yes.
So this one here is minus tan inverse 1, sorry, of p over 3. Now there is a graph. I don't know if you have your odd copy, my brother. That says that the inverse tan graph, it goes like this.
Yes, yes.
Like it goes close to pi over 2. Like it's
Yes, yes.
it goes close to pi over 2. Due to that, they say tan inverse infinity is simply pi over 2. That's just the reason. When you plot the graph of the infinity, tan inverse, it goes close to pi over 2.
Okay.
And this one is tan minus 1 over p over 3. So what is the story, Mr. Trinity? If you have integration by chi, first thing you first prove it.
Yeah.
After proving it, you get now your solution in terms of integration.
Yes, yes.
What? On the phone? Serious?
Yes, my man.
Can you hear
After
the guys?
that, we do the integration and then we get the answer.
Can you hear the guys speaking?
Now, what is next, Mr. Trinity? So that we can move. Can we try this one, my brother? This one I think is a good example for both of us.
Sure, yes, let's give an example.
They said, well, and this one are we proving any existence here? Yeah, we do.
They do, yeah.
Might not be funny either, apart, but it's fine.
We do. We have to substitute.
Like,
Yes, my man.
what's that? Transing.
You say
No, sorry, man.
no, it's fine, my brother. It's fine. It's cool, my brother.
Yes, yes.
It's cool. Okay, Mr. Tinichi, what do we do here? Remember, when we have something like this, you see an E here. You solve the way you know. The E, you only substitute at the end, like the value.
Yes.
So what do we do here, Mr. Tinichi? Because we have this function here, can we first prove the existence? It's division by chi.
Yes.
We're gonna have limit going to t to 0. You can already differentiate, my brother, because you know the first one gives you 0, right?
Yes.
So when you differentiate here, what do we get? We're going to have positive 3
Sine 30.
sine 3t like this, right? Over 1.
Yes.
When we substitute 0, it gives us 0.
Yes.
When we have 0, does it exist? Yeah, it
No,
still does though.
It's not bad.
Now, what is happening, my friend? In this case here, we know what's the thing. What we need to do is we have to solve now for the Laplace of this system here. Laplace
Yes.
that we have here is simply Laplace of 1 minus cos 3t over chi. Do you see it, Mr. Trinity?
Yes.
What we can do, we can split this guy. We can give this one to be Laplace of 1 over p, right, minus cos 3t over chi. Why am I saying p there?
T.
No, do I still have I don't think I have to write the chi again.
You can write P.
No, we don't consider the chi anymore, but we only consider the Laplace of the function on top.
Or is it?
Yeah, the reason why we want to cancel the chi is when we prove the existence. That's the reason why in this case we only solve the Laplace of the guy on top.
Yes.
Yeah, that one. So this one I need to erase it. So basically what we are solving is the Laplace of 1 minus cos theta. Do you see it, Mr. Trinity?
Yes.
So Laplace of 1 minus cos 3t. So what is the answer, my bro? Laplace of 1 is 1 over p, right? Laplace of cos 3t is, let me check the formula again, is p
Over P squared
over p square
plus 9.
plus 9, no?
Yes.
Plus 9. So now we got this one. What we do now, the next thing now, Mr. Trinity, we will have to integrate from p to the infinity. Now in terms of u. Now it becomes u. Now it becomes p. I don't know if you follow the step with me. First, you prove. Second, you get Laplace normally. Third, you bring them in the integration.
Yes.
Why am I writing again
P. That's for you.
Yes. Now, next thing to do, how do we integrate this thing, Mr. Trinity? What is the integration of 1 over u? I'm sure it is ln.
Yes, ln.
Ln. Now, what is the integration? What is this? Why is it ln, guys? If we have f prime of x over f of x, the answer is what, Mr. Trinity? Ln. Ln of f of x. Do we agree here? This one will be ln u, because if you differentiate u, you find 1, right?
Yes.
This one is u square here. What happened in this case down here, Mr. Trinity? If we differentiate the function down, what do we have? If we differentiate u square, it give us what? 2u.
2.
Because 9 is a constant. So basically what we are doing here, we'll add 2 and we have to compensate because it wasn't part of it.
Yes.
So the answer here is simply gonna be minus half the ln of u square plus 9. This time, what is it doing to them? We have p and infinity. So from here, my brother, what do? We've got ln of u, ln of infinity, upper limit minus lower limit.
Yes. Ln of infinity.
Ln of infinity minus half ln of infinity. Infinity square is infinity, right, my brother?
Yes.
Now, minus of the formula. We've got ln of p
P
minus of the formula, and this minus is giving plus, Mr. Trinici.
Okay, yes.
Minus half ln of p
P
square plus 9.
plus
So what do we do from here? We need to find out what is ln of this and this. Let me see how they went about it. Okay, what happened here? Basically what happened is it seems like the whole part here, this infinity here, is giving 0. Why, my brother?
8.
You'll have ln infinity, right?
Yes.
Whatever you do inside here will be infinity.
Yes.
So they both somehow cancelling out. That's the reason here the solution here is only, they wrote it like this: minus ln p minus half, if I can write it like that, right, Mr.
Yes.
P square plus 9. If you see stuff like this, Mr. Trinici, just make them 0, ne?
Yes.
Now what is happening here? What they did here, they just play with some math, because if you have ln of a over ln of b, it is simply ln of a minus ln of b. That's what they kept it like this. They just recall this by saying that the final answer here is simply the ln of p over p square plus 9. But you don't really have to do it like this, to be honest.
Yes.
You don't really have to make it this way.
Yeah, I don't think so.
No, you don't have to make it. What we can do, Mr. Trinici, what we can do even in our sake here, to save ourselves time and stress. This is the answer of the integration, right, my brother?
Yes.
What we do, we come back again, we recall the whole function. What was the whole function? The whole function was exponential, you see, 0 to the infinity, right?
Yeah.
Exponential of t 1 minus cos 2t,
Cos 3t.
cos 3t, cos 3t, everything over t dt to be equal to what? It's going to be equal to this answer that we find. Do you see it, my brother?
Yes.
Lane p like this, you can leave it like that, you don't have to worry about trying to make it nice. Now p square plus 9. Now there will be one thing that will be adding, Mr. Trinici, is the value of p.
Yes.
If t here is minus 1, this one should be what? 1.
1.
Yes. No, it's minus 1. This one is positive 1. Eh? So that
So
one
minus
should be
1.
negative 1.
Yes.
This one is negative 1. So the final solution, Mr. Trinici, we simply substitute negative 1 in our function here, then we have the answer. That is just what it stands there for. Ln of negative 1 square plus 9. We close like this. We've got the answer. Any question, my brother?
No.
Can we move to the next one? One minute is finishing, I'm coming.
Sure.
1 minute, no, please make love to the Trinity, I'm back. Mr. Brian. Hey, my man. It's been a while.
Yeah, no, he just went outside.
Oh, yeah.
But it's been long. I
I
kicked him out. He's disturbing me. Yeah.
we are now old now, man.
We are old.
We grow up very quick. Time just flew. Okay, Mr. Trinity, here's another example. It goes with the same thing, my brother. First step here, Mr. Trinity, what do? We prove, right?
Prove the existence. Yes.
And then we get the Laplace normally of the function on top, which is simply e and this. Okay, I don't want you. I know it sounds like it's a bit confused. Look what's happening, Mr. Trinity. You've got e and you've got this function here. But what we did, we come and substitute here. But in this case, we've got e, but they simply solved it straight using the formula.
Okay.
I know, and I want you to see the difference between these two. This should be, that's where I think we make mistakes as well. Do you see what is the expression here? Okay, no. They said this one gets confusing when you have. Okay, that's what I wanted to show you even. Yeah, I think that's good. You see the difference between each? The one that goes with 0 to the infinity.
Yeah.
That's what I wanted to recall. You substitute. The one that goes with 0 to chi. You can see the difference, right? You just normally solved. You don't do any substitution. But the procedure is the same. I don't know if I can recall it in the way that makes more sense. The procedure of solving this question, Mr. Trinity, what do? We prove, right?
Yeah, we prove.
After we prove, we find the normal Laplace. But on the normal Laplace, we are still including e part of the solution.
Yes.
In the case where it is simply given like this, 0 to the infinity,
you don't include the
e.
Okay.
You only include the e at the substitution.
Oh, okay. Yes.
That's what I wanted to recall. But otherwise, the procedure. Okay. Now I see. Let me make it more clear. Do you remember on this one here? Where is it? Where after multiplication, we said division. Where is it again? There was a place where we divided the function by p again. Okay, yeah, it's this one. Laplace integral.
Yes.
The Laplace integral, now I can say it clearly and nicely now. Where do you know that you got the Laplace integral, Mr. Trinity? It is only when your limit goes from 0 to chi. So it means the solution that you get, you have to divide it again by p.
Yeah.
But what is the difference between these two and what is happening here? The way of solving is the same. But the only difference is the one with the infinity. The exponential, you only include it at the end in the calculation.
Yes.
The one with chi, the exponential, you include it in the formula, and at the end you always divide your function again by p. So what does it mean? If you are asked to solve for any of this thing here, we need to know which type are you. Can we do 1 each here before we go to inverse Laplace?
Yeah, we can do 1.
Which one should we choose, my brother? We can choose between evaluate one each case and then
let's do B.
B. No problem, B.
Yes.
Let's go, my friend. Have you seen my friend? Oh, I'm dizzy. I'm hungry. Okay, Mr. Trinici, first thing we identify, we look at what? We see it's 0 to the infinity, right?
Yes.
What does it mean, Mr. Trinici? It simply means that this guy is out of our range. We're gonna substitute at the end.
Yes.
What is this one? Is this one division or what? Oh, this one is normal integration. You don't need to prove here. I don't know if you see it first.
I don't need to prove.
You prove when you got t here.
Oh, you proven it's division.
This one is
right?
normal integration.
Oh, okay.
What do we do on this one, Mr. Trinici? Let's just do it together. What we do here, we solve now for the Laplace of basically what we're having, it is Laplace of u sinh u. Do you see it, my brother?
Yes.
Because that other guy there, we're gonna substitute him at the end. Now what is Laplace of u? This is the u here simply stands. Basically you are having chi multiplied by sine h like this. So you have chi multiplication here.
Yes.
So what is the formula, my brother? It is minus 1.
Minus 1.
First derivative
D.
of the solution. What is the solution of sin here? It says a. Solution of sin is a. Do you see, Mr. Kenichi?
Yes.
My mind is going. What is a? 1.
1.
Do you see right, my brother? I was copying
Yes.
the formula. It is 1. What is again that one? It is p square plus a square, which is what? P square plus 1. Do you see, Mr. Kenichi?
Yes.
Now you differentiate this one because you are solving for that thing. Huh?
And it's sinh. Isn't it p squared minus a squared? Isn't it minus?
Sin is p square minus a square, ne? Yeah.
Yeah. Just minus 1.
So you have to differentiate this function here, Mr. Kenichi.
Yes.
How do we do that? Can we do the product rule? I mean the quotient rule.
Quotient rule, yes.
Okay, u is 1, right?
Yes.
U prime is 0. It's a constant. V is p square minus 1. V prime is what?
2p.
2p. So if we have to apply it, remember the minus is here. Minus outside here, you have u prime v. You see, u prime is 0 already. Do you see it?
Yes.
Minus v prime u. 2p times 1. So it is 2p. Do you agree, my friend?
Yes.
Everything over p square minus 1. This one gives positive, right? So we've got positive 2p over p square minus 1. Do you agree, Mr. Kenichi?
Yes.
This is what we got as the answer here. So what do we do according to this thing? What do they say? When you have this thing, you always come and write now integration of p to the infinity of the solution. Do you see it?
Yes.
But that solution should be in terms of u. So it's going to be what? 2u u square of what? Minus 1 in terms of du. Do you see it, my friend?
Yes.
Now, what is the answer here, Mr. Trinici? This one gives ln, right?
Yeah.
It gives ln of u square minus 1. Moving from what? Limit moving from what? Infinity and p. Oh, times. I didn't even check. Oh, God. It's the second time I'm forgetting time. I didn't check. Open, please. I need to rest. Trinici. And me and the game.
I don't have a problem. It must be that old evil spirit. So deep down in your girl.
Time finished, I didn't even pay attention.
You may bury my body.
What did I do?
Down by you ended the class.
Oh, je voyais le lien, it's not going through. Try again. We didn't end the class.
That song is very nice.
Hello, it's
Ça,
On a
tu
believe.
dis ça au Congo, on t'amène à l'église straight, hein? Comment tu vas dire que tu vas marcher avec le diable?
Mais c'est qu'il dit? Oh.
She says me and the devil
Oh,
walking by side by side. Listen carefully. She's gonna say.
oh.
Écoute ici. Non, après ça. Yeah, listen to this part.
Hello, Satan.
I believe it's time to go.
Oh,
Me and the devil.
bro, Mr. Tinichi, time just went. I didn't even see that we went over time.
Yeah, I think it just kicked us out.
Yeah. Eh. Thank you, my man. Thank you for supporting me.
No problem.
Now, what is happening here? We have upper limit minus lower limit. Okay.
Wait, I have a question, man.
Yes, ask my brother.
So this is multiplication by t.
Yes. Why is it
So why are we integrating?
The only reason why you're integrating is because you have this one here. Look, I think I have to make it clear.
Oh, okay.
Every function that you have with this infinity here, you always have to bring it here in integration.
Oh, okay.
Otherwise,
Okay,
if it was simple multiplication by chi without this,
Oh,
we are
okay.
done here. We are already done here.
Yeah.
Now we have to bring the solution, cook it again. Sorry, bro.
Yes.
Okay, Mr. Trinichi, what do we do here? Upper limit minus lower limit, right?
Yes.
Remember, this one of the infinity, we can even call it 0, my friend. Yeah? Because when you substitute upper limit, you have ln of. Okay, let's go. It is ln of infinity. Because infinity here will be infinity, right?
Yes.
Minus ln of p. So the infinity here, we don't know what it is. That's why we usually ignore it. Do you see it, my friend?
Yes, I see.
So what we have here, Mr. Trinity, is ln p. Now, we are not yet done. For us to be done now, Mr. Trinity, we have to recall this guy, saying that, okay, this one is 0 to the infinity. They said it was u exponential minus 2u sinh u du to be equal. What we'll have here is going to be minus ln p, but you don't have to forget now this exponential, which is p equal what, my brother? 2.
Is it ln p or is it ln p squared minus 1?
Hey, my friend. Thank you. Thank you. I think it's just tiredness.
Yeah, no, it's fine. Then you just substitute.
Then we
the
just
p there,
substitute the.
which is positive 2.
Now you solve for the quotient. So you'll have ln of minus ln of 4 minus 1. So the answer here is minus ln 3.
Yes.
So what's the difference that I want us to see, Mr. Trinici, is this one is very important. When you see you see like this one is the same as this one. It's the same as this one.
Yes. Yes.
But when you have chi here, we have to first prove. Do you see it, my brother? So
So when it's division.
yeah, when you see division, whenever you see division, I want us to try something with 0 to chi so that you can see when we divide, when we do.
Okay.
I mean, I want us to try something the limit from 0 to chi, right? Like in the example 6.9.
Yes.
So which one? Can we try the first one or second one? Anything, even the third one, it's up to you.
Now let's do the second one.
Second one, yes, my man. Hello. Yeah, can I call you, bro? I'm doing something online. I'll call you back in the next 30 minutes. Sure, my man. Okay. Me and they devil. That's you said. Which one should we do, my brother? No.
F.
Yes, F. I wanted to choose something even with E even. Ash, Mr. Trinici.
Oh, let's do E. It's fine.
No, not anything. It's fine. Now I wanted. Can you do this example as the last one of the day, my friend?
Yeah, it's fine, man. It's fine. It's no problem. Okay, cover the good stuff.
Elle m'a vu work hard. Je pouvais être comme ça toute la journée, je fais refaire ça. Then now I comprends qu'elle doit aller préparer. On connaît Daddy travaille, c'est mon tour de. Ah bon, après comme ça, on te dit oh non, l'enjeu est petit. Ah! Hey, Mr. Trinici, what do we know here? Because this one is a chi here, we can always. Okay, let me see if they prove first. Aish, biggie. Stuff, my friend. Okay, we still prove Mr. Trinici, but on the proving now, we include everything. Are we good, my friend? So when we prove
Yes.
here, we have limit. I hope you can see the difference between the two, né?
Yes.
Now, when we differentiate down, we know down is 1. This is the product rule.
Yes.
So, can we do it quick?
Yeah, okay.
It is U prime V. U prime is the differentiation of expo U.
Yes.
Differentiation of expo U is simply expo U.
Expo.
So, we're going to take it expo chi because we substitute chi here. Né?
Yes.
Multiply by V. V is cosh,
2.
let's say 2 chi, right? Plus V prime. V prime is the differentiation of this, which is 2 sin, right?
Yes.
2 chi. Multiply by V, which is expo chi. So now, Mr. Trinici, when we substitute via our calculator, what do we get? The exponential here will give 1, 1. So what is cosh of 0 plus 2 sin of 0?
It's hyperbolic, man.
You saying, my friend?
It's hyperbolic. 2.
Biggie, l'enfant là a disparu, l'enfant Dieu là. What is it, Papa?
One.
Oh, it is 1. Okay, fine. Okay, Mr. Trinish, what do we do after here? We get normal Laplace of these two combined. Laplace of expo u. Do you see it, my friend?
Yes.
Cos 2u. Now, what is using the formula? But when I write it in terms of, it doesn't matter, u or p doesn't matter. What is it, my brother? Expo my cos is p minus b. So instead, okay, let's just make it p. P minus b. What is b? B is the power of the u. Do you see it?
1.
It is 1. Now, what is down, my friend?
P minus 1 squared.
P minus 1 square
Minus 4.
P minus 1 square minus what?
4.
4. Now, this is the one that you will now bring under the integration of what? P to the infinity. Now, it has to be u minus 1. Do you see it now? U minus 1 square minus 4 in terms of what? Du. But we have to remember. What am I doing here? Let me see. Yeah, we'll get it by. Yeah, this thing is crazy, my friend. You'll keep it in U. You will still bring it again in P.
P.
Or we can just put P here. You write it here. You see what they did? You write solution with P. You substitute with U.
Yeah.
And answer should be P. I don't know what is mocked that day. But it's fine. Hey, this thing is recorded and I'm saying such thing. On te bosser, je vois faire un boss partout.
Tu as fait fou et celle hier, donc depuis elle n'a toujours pas répondu.
Yes, Mr. Trinish, what do we do here? Now we have to solve for this integration. Do you see it, my brother?
Yes.
Ah, this is the problem. How can we solve this one? Hey, Scholars Banning. Can I write it like this?
Yes.
Now, am I gonna find a way of solving this thing? What is this one we must be writing it? Is there a formula for this? Integration formula. I don't think there is something like that because this should be the derivative.
Yeah.
And this one is u, is the function on its own. So I think on this one it can work.
Yeah, thank you.
On this one, maybe we have to use partial differentiation. Long division.
Is it long division?
Yeah, if you expand this one, you will have u. The lower power here will be u squared. You know what, Mr. Finishi? Let me figure it out. I'll write it down and send to you, my friend.
Okay, now it's no problem.
Meanwhile, can you please try this one, my brother?
Yeah, I'll try the example.
Please. Try example and even, please, my brother.
Yes, I will. Thanks, Mr.
Thanks, bro.